Over the past decade, surrounding so-called free energy has collapsed into near silence. This isn't because the topic became irrelevant, nor because the engineering behind it suddenly evaporated. What changed was the attention span of the average human being. Once social media colonized the touchscreen and rewired the way people process information, an enormous portion of the population stopped engaging with anything that required depth, reasoning, or technical literacy. In that vacuum, entire domains of engineering quietly slipped out of public awareness, not because they were disproven, but because very few people were still capable of paying attention long enough to understand them. Today, the development of unconventional power systems doesn't rest with trend-chasing crowds. It sits in the hands of working engineers, industrial technicians, and a small number of individuals who continue to build hardware outside the spotlight. While the world scrolls endlessly, these people manufacture real, tangible machines, equipment powerful enough to challenge long-standing assumptions about how electrical generation must function, yet they operate in a climate where public framing, corporate interests, and industrial politics discourage open discussion. The machinery exists, but its explanation is consistently softened, disguised, or omitted altogether. This is why free energy devices appear on e-commerce marketplaces under entirely ordinary names. No seller will label a generator as overunity or self-sustaining, not because the hardware can't perform, but because such language triggers immediate backlash from automated moderation systems, uninformed buyers, and systems of pressure that prefer certain technologies to remain unexamined. So these machines are listed as PM generators, flywheel assemblies, brushless motors, or low RPM alternators, common labels hiding uncommon design principles. For most consumers, they blend into the background. For those who know what they're looking at, they are anything but ordinary. After a considerable amount of searching, I assembled a list of devices that, intentionally or not, represent the modern remnants of an engineering lineage that refuses to disappear. They aren't marketed as free energy systems, yet their construction points towards something beyond the rigid textbook formulas repeated endlessly in mainstream education. Below is that list, followed by a concise breakdown of the three primary operational principles that unify most modern hidden in plain sight generators. The first category relies on mechanical leverage and inertia, an induction motor driving a heavy flywheel to produce torque large enough to overcome the back EMF of the generator it's connected to. This isn't magic or mysticism, just straightforward mechanical advantage. A sufficiently massive rotational system doesn't need to produce power in the abstract sense, it only needs to maintain motion long enough for the generator to output more than what the prime mover requires at any given moment. Engineers typically recognize these as inertial-assisted generators, even if the public never notices what the system is doing. The second category is far more subtle and structurally elegant. It involves redesigning the internal coil architecture of an AC generator, adding windings, modifying spacing, and incorporating specific electronics to delay or suppress Lenz's law. When the counter-electromotive force is reduced, the generator places less mechanical load on the drive motor. The result is a machine that produces significant electrical output without the proportional drag normally expected. To the uninformed it appears ordinary, to engineers, it's a deliberate manipulation of electromagnetic interaction to unlock efficiency unavailable in standard configurations. The third principle is rooted in abrupt field collapse and pulse charging, exemplified by the Bedini architecture. Here, dual coils are used, one to control rotation, the other to deliver sharp, high-voltage pulse outputs created by the rapid collapse of magnetic fields when the transistor disconnects. The physics behind this is well understood by those who actually study it. Fast collapse yields extreme voltage spikes, and those spikes can charge batteries far more efficiently than continuous current can. Yet many dismiss such devices as toys simply because they do not understand what they are observing. For mainstream engineers, these machines are often dismissed as educational novelties, something that spins, lights a bulb, and demonstrates basic electromagnetic concepts. But the people hired by manufacturing firms, the ones responsible for integrating hardware into real-world systems, do not share that dismissal. They see the underlying architecture, they recognize the potential, and they know how to combine these machines to produce results far beyond what a casual observer would imagine. Their technical fluency is the dividing line between someone who misunderstands the purpose of these devices and someone who can extract their full capabilities. Achieving this level of competence isn't a matter of luck, it requires study, familiarity with circuit behavior, mechanical coupling, winding methodologies, switching electronics, and system integration. In the modern corporate landscape, where energy independence is quietly becoming a priority, those who understand these machines hold an advantage. And because knowledge of this type is no longer readily taught or openly discussed, individuals must seek their own resources. That is why I have assembled a complete digital guide that walks newcomers from foundational concepts all the way to advanced self-powered generator configurations. It covers practical coil work, integration with home electrical systems for reducing monthly consumption, and eventually the construction of fully operational generators, from basic designs that offset electricity bills to systems capable of true off-grid independence. It includes feedback loop architectures, pulse charging techniques, and modern transistor-based field collapse methods designed to extract maximum usable power from minimal input. In an era where attention is shallow and genuine engineering is increasingly hidden beneath layers of distraction, these technologies remain real, functional, and accessible, provided one knows where to look, what to study, and how to assemble the parts.